Hello everyone, welcome to new class. Today's class is the continuation of the problems related to time response analysis. So let us go through the problems. A positional control system with velocity feedback is shown in the figure. What is the response of the system for unit step input? So this is the given system and we have to find the response. So response means the Laplace inverse of the output C of S. So for that we have to find the closed loop transfer function. That is, the closed loop transfer function is C of S divided by R of S, and that is equal to G of S divided by 1 plus G of S H of S, and that is G of S is 100 divided by S into S plus 2 divided by 1 plus 100 divided by S into S plus 2 into H of S is 0.1 S plus 1, that is 0.1 S plus 1. Now take the LCM, that is here we get 100 divided by, that is after taking LCM, and we can cancel this S into S plus 2 here and here. So here we get S into S plus 2 plus 100 into 0.1 S plus 1, and that is equal to 100 divided by here S square plus 2S plus here we get 10 10S plus 100, and that is equal to 100 divided by S square plus 12S plus 100, and here the characteristic equation is S square plus 12S plus 100, and we have to find the roots of this characteristic equation, and here we cannot factorize, and so we have to go for partial fraction expansion. That is, here this is C of S divided by R of S. Now, and we have to find C of S, that is equal to R of S into 100 divided by S square plus 12S plus 100, and R of S is, it is given that unit step input, so R of S is equal to 1 by S into 100 divided by S square plus 12S plus 100, and by partial fraction expansion we get C of S equal to 1 divided by S into 100 by S square plus 12S plus 100 equal to A divided by S plus this S square plus 12S plus 100. So we can write BS plus C divided by S square plus 12S plus 100. Here the value of A can be obtained by multiplying C of S with S and putting S equal to 0. That is, here multiplying this C of S with S, we get this 100 divided by S square plus 12S plus 100 at S equal to 0. That is, put S equal to 0, then we get 100 divided by 100. So we get A equal to 1. Now to get the values of B and C, here we have to cross multiply. That is, here this is 100 divided by s into s square plus 12s plus 100, and that is equal to a into, here take the LCM, or we can say that cross multiply the coefficients, that is here a into s square plus 12s plus 100. So cross multiply the denominators, then plus bs plus c into s divided by s into s square plus 12s plus 100. So here we have to take the LCM. Now these two are get cancelled. So we get 100 equal to a into s square plus 12s plus 100 plus, here we get bs square plus cs. Now we have to equate the coefficients of s square, then s. That is, by equating the coefficients of s square, we get here no terms of s square, so 0 is equal to a plus b. That is, equate the coefficients of s square. So here a, here b, that is a plus b equal to 0. Now equate the coefficients of s. Here 0 equal to 12a, then plus c. And we have the value of a equal to 1, so we get b equal to minus 1, and here on substituting the value of a equal to 1, we get c equal to minus 12. Now substitute the values in this equation. Let it be equation 1, that is c of s equal to, that is equation 1 implies c of s equal to 1 divided by s plus bs plus c. b is minus 1, that is minus s, then plus c is minus 12 divided by s square plus 12s plus 100, and that is equal to 1 divided by s. This minus we can take here, that is s plus 12 divided by s square plus 12s plus 100, and here this 100 we can write as 1 divided by s minus, here s plus 12 divided by s square plus 12s plus, we can write 36 plus 64. So that here we can write s plus 6, that is x plus 6 the whole square, and also here we can write s plus 6 plus 6, that is 1 divided by s minus s plus 6 plus 6 divided by s plus 6 the whole square plus 64, and here we can take this one and this one separately. So here we get 1 divided by s minus s plus 6 divided by this s plus 6 the whole square plus 64, we can write 8 square, then minus this 6, that is 6 divided by s plus 6 the whole square plus 8 square, and here on multiplying here 8 and dividing with 8, multiply and divide with 8, so we get 1 by s minus s plus 6 divided by s plus 6 the whole square plus 8 square minus 6 by 8 into 8 divided by s plus 6 the whole square plus 8 square. And this is in the form of s plus a divided by s plus a plus omega square. And this is in the form of omega divided by s plus a plus omega square. We have the Laplace transform of sine omega t is equal to omega divided by s square plus omega square, and the Laplace transform of cos omega t is equal to s divided by s square plus omega square. So here we have to find the response, that is response C of t is equal to L inverse of C of s, and that is equal to L inverse of 1 divided by s minus s plus 6 divided by s plus 6 the whole square plus 8 square minus 6 by 8 into 8 divided by s plus 6 the whole square plus 8 square. And the Laplace inverse of 1 divided by s is 1. Then minus, here this is in the form of s divided by s square plus omega square, and that is cos omega t. So we get a cos 8t, but here instead of s this is s plus 6. So here we have to put e raised to minus 80, that is here e raised to minus 6t into cos 8t, then minus 6 by 8 into, here this is in the form of omega divided by s square plus omega square, and that is sine omega t. So we get sine 8t, but here also this s is s plus 6. So we have to put e raised to minus 6t into sine 8t. So this is the response in time domain. 1 minus e raised to minus 6t cos 8t minus 6 by 8 e raised to minus 6t sine 8t. Let us do another example. The unity feedback system is characterized by an open loop transfer function g of s equal to k divided by s into s plus 10. Determine the gain k so that the system will have a damping ratio of 0.5 for this value of k. Determine the settling time, peak overshoot, and time to peak overshoot for unit step input. So this is the given open loop system, and we have to find the value of this k, and the damping ratio is given, that is zeta is given as 0.5, and we have to find settling time, then peak overshoot, then time to peak overshoot. Time to peak overshoot means peak time. So first of all we have to find the closed loop transfer function, and that is C of s divided by r of s equal to g of s divided by 1 plus g of s, because it is given that a unity feedback system, so h of s is unity. So here we get g of s is k divided by s into s plus 10 divided by 1 plus k divided by s into s plus 10, and that is equal to k divided by s into s plus 10 plus k, and that is k divided by s square plus 10s plus k. So this is the closed loop transfer function. Now compare this equation with the standard second order form. That is, standard second order form is omega n square divided by s square plus 2 zeta omega ns plus omega n square. Now we can compare. That is, here omega n square. Omega n square is equal to k, and we get omega n equal to square root of k, and 2 zeta omega ns equal to 10s. So we get omega n is equal to 10 divided by 2 zeta, and zeta is 0.5, that is 2 into 0.5, and omega n is root k, that is square root of k is equal to 10 divided by 2 into 0.5, and that is equal to 10. So we get k equal to 10 square, that is 100. And also the value of omega n is this 10. So value of k is equal to 100 and omega n is equal to 10. And now we have to find the settling time, peak overshoot, and time to peak overshoot. So the percentage peak overshoot. Percentage peak overshoot is equal to e raised to minus zeta pi divided by square root of 1 minus zeta square into 100, and that is equal to e raised to minus zeta is 0.5 pi divided by square root of 1 minus 0.5 square, then into 100, and that is equal to, we get 16.3 percentage. And to find the peak time Tp is equal to pi divided by omega d, and that is pi divided by omega n into square root of 1 minus zeta square, and that is equal to pi divided by omega n is 10 square root of 1 minus 0.5 square, and we get 0.363 seconds. Now to find the settling time Ts equal to, it is 4 divided by zeta omega n for 2 percentage error, and that is equal to 4 divided by 0.5 into 10, and that is equal to 4 by 5, that is 0.8. And also settling time Ts is equal to 3 divided by zeta omega n for 5 percentage error, and that is equal to 3 divided by 0.5 into 10, and that is equal to 3 by 5. 3 by 5 is 0.6. So this is seconds. So that is about the problem. So thank you for watching the class. If you like the classes, please like, share and subscribe my channel.